Hello guys, so welcome back to our lab for analog circuits, and today we're gonna explore lab 4. And lab 4 is basically based on clipping. So we're gonna study in that lab or verify basically what we take in theoretically in our lectures about positive and negative clippings. So if you guys recall from our this week's lectures, we explored or studied two different circuits. One of them that makes clipping at the positive half cycle of the input sine wave, and the other one makes negative clipping. Okay, today in that lab here, we're gonna verify the first one, and also for the second or for the negative clipping, I'm gonna explore another circuit. Basically it's the same, just with just one simple change. I just flipped the diode. Okay, but it's a negative clipping. Okay, so let's explore our first experiment, which is positive clipping, in which we're gonna clip at the positive half cycle of the input. So here is the manual, as you see, guys. It's the experiment one from lab 4. You're gonna construct this circuit. It's an easy circuit. Okay, we know where to find all these components. Here we need two oscilloscopes. The first one is gonna measure the input. So the positive here at the this terminal of the input, and the negative is the ground, which is the second terminal of the input. So you don't need to connect everything to one ground simply if you have more grounds in the circuit, but all of them is of course is just one thing. Then to make your circuit drawing neat and beautiful, you can just make other grounds here and connect whatever need to be connected to ground to it. Then the second oscilloscope is to measure VR, as we take in the lecture, and also VO or V output. So V output is between this point and the ground, which basically VD plus VB. And this is gonna measured by B. Look at B, the positive of B is connected to that point, and the negative of B is connected to the ground. Okay, and the VR is the voltage across the resistance R. It's gonna be measured using the channel A. As you see here, the positive of the channel A goes to this point, and the negative goes to that point. Okay, good. So in the beginning, we're gonna measure the input itself. So here is, of course, the connection. This is, this circuit is just this circuit, no change at all. And I'm gonna run it. So let's see, now we have two oscilloscopes. To see the output, we must, double click on each one to see the output. So basically, let's concentrate first on the, on the input, the reading of that oscilloscope. And here it is. So it's a sine wave, okay? And as you see, this is 14 volt RMS. For you guys, for whom of you that don't know what does RMS means, basically we explore the outlet, the electricity outlet that we have in our homes here. This outlet, standard output, produces a volt, which is 110 volt RMS. Okay. Just to forget about what is RMS, what does that mean? You can convert easily to RMS to the things that you know. What you know, for example, the maximum, this maximum point, or the peak to peak. So basically 110 RMS is basically 110 times square root of 2. This will give you the maximum volt here. Okay, so in our case here we have 14 volt RMS. 14 multiplied by square root of 2. Square root of 2 is just, it can be approximated to 1.4. So it will be around 20 volt. Just do it using calculator. So it will be around 20 volt. So if we measure the out with the input here, okay, if we measure the maximum here and look at the, this marker. So this is the maximum here. Look, it's 19.7. As I said, it's around 20. Okay. So that's basically your input. So you're gonna, take a screenshot here and put the screenshot here in that square. So, but I wanted to do something, specific here to reverse the input, to reverse the background. I'm sorry. So here the background that I'm showing you is black, and it will be all the time black. But for you, for any drawing, any screenshot you should do with the white one. Okay, I will not repeat that again. You should take this in your mind that please put here with white background. Okay, just to make sure that you are taking screenshots from your, from your experiment, not from my experiment here. Good. So that's it for V input. We know now how V input looks like. It's a sine wave, just like the ones that we see in our lecture. And now we go to the second part of our experiment, which is, yeah, measuring the output, which is the voltage across the diode and the volt is the battery VB here. And we know from our lectures that the clipping should be done at VB plus VD. Silicon diodes usually, conduct at VB equal to VD equal to 0.7. So we know the clipping should be at 3.3 plus 0.7. It should be 4. Of course, this is not, this is an actual diode, okay, or can be modeled as an actual diode now. So we don't have the constant voltage model. So don't expect it to be 0.7 exactly. It will be something close to 0.7. So let's check that. So we still have its run the simulation running here. So let's double click that guy, and let's now set our oscilloscope to that settings here. So YT, then for A make it 0, then for B make it DC, and this is basically the output. And here is the clipping. Okay, so if we measure that, select trace, make it B because it's a channel B basically. And now here is, the yellow marker, so it's basically 3.984, which is very close to 3.3 plus 0.7. So the theoretical value here, it is 0.7 plus 3.3, it should be 4. But the actual value, or I'm sorry, the measured value, or the actual value, yes, is 3.98, which is very close, very close. And here is, how to measure the error. It's basically the absolute value of the measured minus the theoretical divided by the theoretical. And why it's absolute? Basically because we don't care about if the measured is greater or less than the theoretical value. In both cases, it's error. Either it was greater or less, it's error. Okay, so that's why we don't care about the sign. So just make the absolute. Okay, that's it for the for the output. Now we want the input. I'm sorry, we want VR. VR, remember, is channel A. So same oscilloscope, but a channel A. So that would be this part here. So we're gonna now ground the channel B, which is the output, and re-enable channel A using that DC or direct coupling button here by pressing it. And here is basically VR. If you recall our lecture, this is what we get exactly in our lecture. When we analyzed this circuit here, we analyzed exactly the same circuit, and this was the shape of VR. Good. So now it's time to measure this value here, and this is really easy. So again, image. It's not selected for channel A, so make it channel A now. And yes, it is here. So look how it is. It is 15.7. Okay. Good. Now it's time to add them together. Remember, guys, this is VR, and this is so I'm now drawing them together, and this is VD. And remember, V input, if we look here at this circuit by Kirchhoff, V input equal to VR plus VO. Sorry, not this is not VD, this is VO. VD is equal to, I'm sorry, VO is equal to VD plus VB. And remember, from our lecture, we knew that V input equal to VR plus VO, which is the voltage basically on VB plus VD. Okay, and when we add VO to VR, we should get exactly V input. So in that time now, I'm gonna get this on the side here and open V input. And when we add these together, we should get exactly this shape. Okay, how we do that? There is, in common oscilloscopes, there is a button called add, which adds the two inputs, channel A or channel B, together, or channel X and channel Y according to the oscilloscope. So now using this button here, this add one, we're gonna add them together. Okay, and as you see here, guys, this is exactly this one. Okay, let's verify more because this is a lab. We should, quantify everything. So we're gonna measure, the peak-to-peak value of the input and the peak-to-peak value of that addition, and these should be exactly the same. Look, so let's measure first, the adding. So remember, this is the adding. So we're gonna move that guy here to the peak, for example, and move this marker 2 to the bottom. And this value here basically is a subtraction between 1 and 2. So this is 1 minus 2, which is 19.63. So you should write here 19.63. Okay, I'm expecting that yours should be different. Not that different. I mean, it should be 19.67, 68, or 19.7, or 19.1, or 20 point something. So please don't just put that number. I mean, you should put what you get in your experiment. So now let's measure the input peak to peak again. So let's put at one at the peak, or positive peak, and 2 at the negative peak, because basically what you get here is subtraction. And as you see here, guys, from time to time, accidentally a multisim changes the marker position, so you should redo it again. No worries about that. So here it is, and here is Mr. 1. Yeah. And here is the subtraction, 19.614. As you see, they are very close to each other. This is 19.61. This one 19.67 or something. Let's make it again here. Yes. And yes, 19.7, as you see. Okay. That's basically, experiment 1, which is, positive clipping. Now let's go to the second experiment, which is negative clipping. So remember, guys, from experiment 1, this was the clipping at the positive, half cycle of the input, of the sinusoidal input. So in the second experiment now, we're gonna explore another circuit, this circuit here, with two different or two variations now from the first circuit. Basically, the first one is that we have here, the diode is flipped. Okay, so if we go back here, I'm going to show you. Look at the diode here. The diode has its N toward the positive terminal of B or VB, and B is toward the resistance. Here it's opposite. The B is connected to the positive of BB, and the N is connected to the terminal of the resistor. Okay, that doesn't change anything in our analysis. Okay, except for one thing, which is the input minimum, at which we call the lecture again. This the input minimum is the input at which the diode will start to conduct, to be on. So in our lecture, when the diode was reversed, I mean, flipped, not like this, with the same VB, the V input minimum was 0.7, plus 0.7, minus 3.3, or minus VB, whatever it is, okay, or plus VB and VB, whatever it is. So VB is minus 3.3, so 0.7 minus 3.3. Now, after flipping the diode, it will be minus 0.7 minus 3.3. So it will be minus 4. If we left the diode, in the other position, I mean N toward the positive terminal of B, and the B of the diode connected to the resistance, to be plus 0.7 minus 3.3. So it will be 2.6 minus 2.6. So that's the only difference. Okay, but I wanted just to show you the more common shape of that negative clipping circuit. This is the more common shape. Okay, so based on that, we are now expecting to have a negative clipping at minus 3.3 minus 0.7, which is minus 4. Okay, so let's see that. Let's check that. So we have here the same circuit again. Let's run it. Input, of course, doesn't change. It is still the same. And now here it is. Of course, it's adding now. So let's go back to YT. Okay, and let's check first the output, which is on channel B. Look, this is VO, and here is the clipping. You know, let's now measure this clipping. So let's make the marker to refer to channel B, and here it is. Look, guys, look at the yellow marker is the second one here. The second reading. Okay, the second reading here is minus 3.98, which is approximately minus 4, as we were expecting, right? So you should, you know, put here the theoretical value, which is minus 4 exactly, and here is you should get what you have, whatever you have. Of course, it should be very close to minus 4. Okay. Otherwise, you will have some problem in your measurement, and you should redo it. Okay. Okay, now VR. So VR, remember, this is the second oscilloscope. Second oscilloscope here measures both VR, which is channel A, and the channel B, which is the output. So now we are measuring channel B. Now we want to measure channel A, which is VR. So put it at 0, ground it, and put that at DC. And here is VR. And this is exactly what we got in the lecture. Okay, again. We are just verifying the theoretical stuff using, you know, a real lab setup. Of course, it's not real, it's virtual, but, you know, something close. Okay, now let's now do the addition. And remember again, if we go back to the, let's draw them together. So just put the DC. Remember, this is VR and this is VO. And again, V input from Kirchhoff equal to VR plus VO. So when we add them together, we should get exactly VO. You have these glitches, you know, sometimes that, you know, some one of them is just, you know, vanished. So make this. So you see this single here, make it none, then make it single again. Now you have it. So this glitch, you know, don't worry about it. Just, you know, make it none, then single again. And here is the addition, guys. Now let's compare this to V output. They should be exactly the same. I'm sorry, V input. They should be exactly the same. This is a pure V input from the source, from here. And this is basically the addition of VR and V. Let's make it YT again. So this is VR, this is VD, then we add them together. Okay. We know the peak-to-peak voltage from that guy. So let's now measure the peak-to-peak voltage of that guy. So make it A plus P, yes. Then, okay, marker 2 is at the, you know, the negative peak, and marker 1 now at the positive peak. And here is the difference between them. I'm sorry, this is the difference between them. It is, yeah, because it's marker 2 minus, I'm very, very sorry. So this is, you know, this guy, this value here is marker, is marker 1. This is marker 2, and here is the marker 2 minus marker 1. I was wrong about the first experiment, so I gonna redo it with you guys because of this misunderstanding from me or confusion from me. So basically, this reading here is marker 2. The first reading is marker 1, basically 1 and 2. Then here this reading is 2 minus 1. So let's put to make it positive. Make 2 at the positive peak, and make 1 at the negative peak. Okay, and now, yeah, now this is 19.7. This guy is minus 19.57. So this is subtraction between them. Of course, minus will be positive. So this will give you the peak to peak value, which is around 40, just like this guy. Remember, the maximum here is 20. So peak to peak is 40. And just to remove any confusion you have, if we go to experiment 1, run it again. And here is the addition, you know, if we just make it YT again, here is the two signals together, then we add them. And here is, you know, I'm gonna measure again the peak to peak because I messed up with the marker meanings. So let's start by marker 2, select trace A and B. So marker 2 is at the positive peak. Let's make it at positive peak again by ourselves to be sure that it's really the peak. Yeah. And this is marker 1. Yeah, it's a negative peak. So this reading here is marker 1. This is minus 19.7. This reading here, second reading, is marker 2 at 19.6. And here is the 2 minus 1, 19.6 minus 19.7. So it will minus will be positive. So this will give you around 40 or 39.425. Okay, so this is basically, guys, the positive and the negative clipping. Okay, it's really nice circuit. It's really, doable and smart, and but very, very doable. Just, watch the lectures, understand, try to understand them, try to do the examples in the lectures yourself, okay, to better understand the situation. Then if you can by yourself, you can change this value, okay, VB. You can change the position of the diode, you can reverse it, make it, like this, or the opposite connection. Then if you just, stuck at any point, just draw this, draw this, the circuit that you just, that you are experimenting or that you are analyzing in Multisim, and try it on Multisim and see. Multisim will give you a good idea about the solution. Of course, it will give you the final output without any analysis. Analysis is yours. Paper and the pen is just your way. Multisim do it in his way, okay? But it will give you the solution. Now it's your turn to analyze how we can get to that, shapes in the output and VR. Okay, so that's basically the how we use Multisim. It's not just a lab. So Multisim can help us basically to understand better, the theoretical stuff that we take. Okay, and again, if you're stuck in any circuit, just try many values for VB. Okay, try many situations for the slide, just like this or the opposite way. And if you're stuck in anything, or if you analyze something and you want to verify, just try it on Multisim, just like this. Okay, you can change this value to whatever you want. You can change the position of the the diode in whatever situation you want, and just see. Okay, thank you very much for this. I hope it's useful for you guys, and good luck with that lab. Bye bye.